Look, if you had one shot and one opportunity to figure out what made you really sick with diarrhea, would you capture it or just let it slip? Yo, his palms are sweaty, knees weak, arms are heavy, there's vomit on his sweater already. Mom spaghetti? Hi everyone. Welcome everyone, and I'm glad you can all make it because there's probably some people challenged with diarrhea problems at home that couldn't make it tonight, but I'm glad you guys are all here. And so, with that, have you ever wondered what was the last time that you had severe diarrhea? And for all the German speakers in here, I know that you probably don't know what diarrhea is. Durchfall. Durchfall. So, if you think about the last time you had Durchfall, you'd probably say, yeah, I think I had some sketchy Leberkäse or some schnitzel, and that was really bad. But very few times in your mind does it come across that it could be probably because of our water. It's almost unimaginable, especially here in Vienna, right? We have some really good quality drinking water. So, we have a lot of technologies that we can use to help treat our water, whether it be UV disinfection or chlorine. We've been able to kill a lot of the bugs, but on the other hand, there are some bugs that are a little more challenging to deal with. And so, how do we actually check that our technologies are actually treating the water to a very good drinkable state? Well, the obvious answer for a lot of us is, why don't we just test the water? That's the simple solution. Well, I'll tell you why it's not as simple with this demonstration. Lights, please. All right, so suppose we have this tank which represents drinking water, and it's very clean, but all of a sudden there's a pollution event and it gets contaminated. And so we have some chemicals. And we also have a microorganism that might actually fall into our water, okay? And so we can actually sample and test this water. And here we go. We have a sample here. We're gonna take a second sample here. And last but not least, we're going to take another sample. And as you can see, the chemicals can be detectable in every single sample that we take. But in order for us to capture this one microorganism, it's actually really, really difficult because there's only one of them, right? So you can turn back on the lights, and really, this is the needle in the haystack that we're actually looking for. So, with this needle in the haystack, let me give you another analogy. Why are we looking for such a small thing? And how do we actually find this very small item that's present in our water? Now, Wiener Wasser, on average, every single day, produces enough water to fill up all four of our gasometers that's down the streets. Every day. But on the other hand, we're trying to find something that's this small. And if you imagine this room right here, the stage, okay? If it was a single grain of table salt, the microorganisms that we would be looking for is no bigger than the size of the soccer ball. And so there, whoever caught it, you're infected. All right? And some of these microorganisms, harmful microorganisms, could be as small as this size right here, which is even smaller. Okay? And so that's the first challenge, finding some of these microorganisms with creepy names like cryptosporidium that can actually harm us. Now, moving on to our next point. Well, Alex, we can treat a lot of the water, so how do we capture this 1 in a million? Let's look at how much is in our actual source. There's probably a lot more in the environment because it's open to pollution sources like sewage treatment plants. And then, from the sewage treatment plants, because there's so many more of these that we can find, then we can actually design our treatment to provide adequate treatment. And then by subtraction, you take what, you can find a lot of those, you subtract, you design, engineers can design, do their little funky math thing, and finally come up with an answer that says, this is clean drinking water. So appreciate it when we can actually have drinking water for granted. Now, the other challenge that I'm about to talk about, which is the core of my PhD, it's actually looking at the natural subsurface filtration systems. In Vienna, we actually have a lot of groundwater systems that we can use in order to treat our drinking water. And with those systems, the subsurface we're actually using, it's so vast, it's so mysterious. And when you look into the black box, you take one step over in the ground, the conditions have already changed, and it doesn't have the same capacity in order to remove those organisms that are so harmful to us. And so, if we can actually understand what is going on, we know how many there are in the beginning, we know what our treatment does, then we can finally come up with Kaltes, klares Wasser. And with that, let's seize the opportunity. Thank you. Dankeschön.